Welcome to Microlecture 31. I'm going to teach you here how to name alkenes as E or Z alkenes. Alright, the rules for defining alkenes as containing E or Z stereo configuration are as follows. First, we want to label each substituent on the double bond carbon atoms as high or low. Okay, we're going to use the same prioritization rules that we used when we were naming R and S stereocenters. So let's do that on the right-hand side examples. So I'm going to take this carbon atom here, and we kind of look first on the left and then on the right, or first on the right and then on the left, doesn't matter. So we're kind of splitting the carbon double bond and looking at each side in turn. So I'm comparing here a bond to a carbon atom of a methyl versus a bond to a hydrogen atom. And you can write that hydrogen atom in if it helps with clarity. And so I'm seeing that a carbon beats a hydrogen, and so this group would be considered higher priority. The hydrogen is a lower priority. And we do the same exact thing on the other side. Draw in the hydrogen if it helps, but what we're seeing there is that we have a high priority down here and low priority up there. And so then you just take a look, rule number 2, and see if the two high priority groups are close to one another, or they're on the same side of the double bond. We think it's Z. And if the two high priority groups are far away from each other on opposite sides of the double bond, then we would say it's an E alkene. Well, these two high priority groups are on opposite sides of the double bond. So for that reason, I'm going to label this an E alkene. So doing the same exact thing now with the molecule below. I'm going to go ahead and label the hydrogen atoms that are there just for clarity. And I see that a hydrogen takes low priority and a carbon of a methyl high priority. And over here, low priority, high priority. And what we're noticing is that the high priority groups this time are on the same side of the double bond. They're near each other. And so that's why we're going to designate this as a Z alkene. Let's take a look at two more examples. Okay, so on the left-hand side, I'm going to label the bromine high priority and the methyl low priority because bromine has a larger atomic number than carbon. And then I'm going to label the ethyl group high priority and the methyl group low priority. Again, same rules that we used in R and S priority rules. And so the high priority groups are indeed on the same side, and so this would be a Z alkene. Go ahead and do that again. Nothing changes over here because this side of the molecule looks exactly the same as it did before, so bromine takes priority over methyl. And then what's different here is that I have a carbon going to an oxygen with my aldehyde functional group hanging off of the double bond here, so that's actually the higher priority, and now the ethyl becomes a lower priority, and the groups of higher priority are far away from each other on opposite sides of the double bond, and so this would be an E alkene. One trick for just remembering that Z goes with the same side is to say same side. Alright, so the high priority groups are on the same side.